Hello everyone, I am Naela S. Adtugan and this is the part 3 of my midterm exam in EDSI 130 Electricity and Magnetism. Today we will do an experiment about magnetic field entitled Magnetic Field in Fluid. Magnetic field is a region around a magnetic material or a moving electric charge within which the force of magnetism acts. Thus, our experiment Magnetic Field in Fluid shows a scientific demonstration that illustrates how magnetic fields typically created by magnets interact with a fluid medium such as water or a liquid. Let's start our experiment. In this experiment, the materials we will need are 4 magnets, iron fillings, clear plastic bottle, and water. The first step is place the clear plastic bottle on a flat surface. This container will hold your water and the iron fillings. Next, carefully pour water into the container, but not too much. You want just enough to cover the bottom. Make sure the water surface is level. Third step is sprinkle a small amount of iron fillings evenly over the water surface. Fourth step is place the magnets at the bottom of the clear plastic bottle so we can wash the iron fillings for clearer visibility. Using the magnets at the bottom of the bottle, pour the water out into other container. Now pour a clear water again into the plastic bottle. Now it's time to introduce the magnets. Gently lower it into the container of the water. You can move it around to see how the iron fillings react to its magnetic field. The iron fillings will align with the magnetic field created by the magnet. You'll see patterns and lines forming in the water. Let's take a look at this experiment a little closer. There are 3 components important in our experiment. Magnets, which create the magnetic field that we'll be observing in our fluid, iron fillings that will interact with the magnetic field and help us visualize it, clear plastic bottle that will hold the fluid, and iron fillings, allowing us to see the magnetic field patterns clearly. Magnets have 2 poles, a north pole and south pole, which generate magnetic lines of force that extend from the north pole to the south pole. When placed near water with iron fillings, the iron fillings become tiny temporary magnets themselves due to the influence of the external magnetic field. As the iron fillings are influenced by the magnetic field, they align themselves along the field lines. They do this because each iron filling's own magnetic field attempts to align with the external magnetic field to minimize energy. This alignment creates visible patterns in the fluid, showing the shape and direction of the magnetic field. These patterns can help visualize the strength and direction of the magnetic field. Thus, we can conclude that the magnetic field is important in our life. It protects our planet from cosmic radiation and from the charged particles emitted by our sun. The rotating magnetic fields are also used in both electric motors and generators. The plants and animals would not also survive without magnetic field because the sheer strength of the Earth's magnetic field helps to maintain liquid water on our blue planet's surface, thereby making it possible for life to thrive. That concludes my experiment magnetic in fluid. Thanks for watching!